Hi, this is Dr. Nerz-Stormes in my office working on Stereochemistry 4, which is going to accompany a book on stereochemistry, which you will find on the web in the fall of 2010. And we hope this will be really helpful to learning stereochemistry. In this part of the series, what I'm doing is teaching you a different way to draw a stereocenter in 3D, and also how to assign them, okay, and how to tell the difference between molecules. What are the relationships between molecules? So what I've done is I've drawn a bunch of molecules up on this board. These molecules could be the same, or they could be enantiomers, all right? Now, the reason I drew them the way I did is I wanted to get you used to an idea called a Fisher projection. And Fisher projections are very useful when you're learning about sugars or molecules that have multiple centers, and that's going to be one of our next topics. What is a Fisher projection? Well, a Fisher projection is a shorthand notation for a 3D structure. So when you see this projection, the intersection of the two lines is the asymmetric carbon. So that's the asymmetric carbon right there. The horizontal lines are coming out towards you like this. Okay, so the horizontal lines are coming out like two wedges, like that. The vertical lines are going back like that. And that is the way it is always defined. So in a Fisher projection, there are no bonds in the plane of the board. The front bonds are like this. The vertical bonds are like that. The great thing about a Fisher projection is that nothing is in the plane, and nothing is in the plane. And because nothing is in the plane, you will have no problem assigning them, okay? These are kind of the traditional wedge and hash drawings, and you probably should put the H's in to help you. And put the H's in properly. Don't put the H's like this. This is not a proper 3D drawing. I want you to think about that. Okay, so I'm going to put it in properly. This is another Fisher. Again, these are wedges. These are hashes. Okay, so how do we deal with this? If we want to figure out the relationships here, we want to find out what's going on. What is the relationship between these molecules? And we want to start using Fishers. Okay? What we have to do is assign them, because assignment is going to be your tool to everything. Assignment defines the stereochemistry. The only molecules that are the same as R are R molecules. The only molecules that are the same as S are S molecules that have the same connectivity. But if you get an S and an R, they're enantiomers. So let's do this. So if I look at this center and I assign this, we already did the work on the last problem, because this is really the same molecule, or very close to it. This is going to be number 1. This is obviously number 4. Let me get rid of these because they're kind of annoying. Okay. Now this is a methyl with 3 H's on it, right? And this is a carbon with 2 H's and a carbon on it. Now, first point of difference, these tie, but this one's going to win because of the carbon on it. So this is number 2, and this is number 3. Now, we've done all the work. You don't have to keep doing this over and over again. You don't have to build models to solve this kind of problem. That's our question. Relationships, are they the same, or are they enantiomers? All right, this one. 1, 4, because that's an H. 3, 2. 1, 4, 2, 3. Whoops, backwards. 2, 3. 1, 4, 2, 3. Okay, we did all the work. They're the same groups. These molecules have some relationship, or they're the same, because they have the same connectivity. Okay, let's assign them, because assigning tells us everything. So, this is 1, this is 2, this is 3. We trace the circle around, right? And we get a counterclockwise circle, so it looks S. The question is it really S? It is really S because number 4 is oriented away from you. How do you know it's away from you? This number 4 is sitting on a vertical line, right? and the vertical lines in a Fisher projection go back. So this one really is S. Now I'm going to show you how to deal with it when it's not drawn in the most convenient fashion. Okay, we did these already, so this one is R, and it really is R, because this 4 is going back, and this one is also R. And notice it's just drawn, it's like tipped over. Did I have to use a model to establish that? No, I just had to assign it. Now let's look at this one because it's a little different. 1, 2, 3. Now watch. You trace the circle from 1 to 2 to 3. But what's peculiar about this? What's peculiar about this is number 4 is on a horizontal in a Fisher projection. That means it's coming out towards you, right? That means that that position defies the rules, and rules are arbitrary, right? They're not meant to be broken, like everyone says. Rules are meant to be broken, but they're arbitrary. Kahn, Ingold, and Prelog were 3 men. They just decided, I'm not picking on them because they're men, 3 male scientists. They just decided arbitrarily this is how these things are going to be named, and it works very well. But sometimes drawings are drawn such that number 4 is coming toward you. How do you deal with that? It's very easy. What you do is you trace the circle from 1 to 2 to 3, and you say it looks like it's S. It looks S. But it's not S. It's really R. So what I'm saying to you is if number 4 is pointing toward you, reverse the designation. Now, think about this. I don't use models a whole lot, but what I like to do is I like to transport myself through space to do stereochemistry. So imagine this. Imagine if I went behind the board. If I was standing, I'll make myself in green. Imagine if I was standing behind the board. This is me. I'm behind the board. I'm out in the hall. I could go out in the hall. I'm going to run out the door, go out in the hall. Okay, I'm behind the board. If I was behind the board, this little person here was tracing from 1 to 2 to 3. That's what it would be like for me behind the board. Now, what's so great about behind the board? Behind the board, this would be going away from me. Does that make sense? Like if the H is here, and I'm behind the board, the H is now away from me. So where would bromine be? Bromine would be down by my feet. I'm picturing myself behind the board. Number 2 would be up by my head. And number 3 would be over to the right. So when I trace the circle from 1 to 2 to 3, I'm going to come around so that I'm facing you. This is like turning the molecule around. Which way is it? It's clockwise. What is clockwise? It is R. I didn't do anything really tricky there. I put myself in a position so this was away from me. Okay? So the outcome of that, like if you want, this will get you through almost any problem. If number 4 is coming toward you, do not move the molecule. Do not build the molecule. Trace the circle and then reverse the designation. It works really well. Okay, so in our next video, Stereochemistry 5, we're going to start to work with 2 centers. So check out Stereochemistry 5.